Okay, so we will be starting from what are the common acids whose formula we people have to memorize. And this is very important in this topic. For example, HCl is hydrochloric acid, H2SO4 is your sulfuric acid, and then HNO3 is your nitric acid, and H3PO4 phosphoric acid, and H2CO3 is your carbonic acid. Okay, so the formulas of these acids. Along with this one, there is another acid which is CH3COOH. This is called ethanoic acid, and this is an example of a weak acid. So that is why we have to memorize these formulas of the acids. After that, what we need to do is we have to memorize the formula of alkalis. Now I am writing down an alkali. First of all, I will write down the definition of an alkali. Alkali are soluble bases. Alkalis are they are hydroxides. Alkalis are इसको we can even write it down soluble metal oxides. So you should know what an alkali is. Now let's talk about the examples of alkalis. Sodium hydroxide, potassium hydroxide, um, ammonium hydroxide, and the very important thing is that what is the formula of an hydroxide? The formula of hydroxide is OH negative 1, and the rest, that either it has a sodium ion or a potassium ion or ammonium ion, that you have to memorize it. The formula of ammonium ion, that is also you have to memorize, NH4 positive 1. This thing also you have to memorize. Okay, now let's move on to the indicators. I am going to show you people a screen from the book, and there please mark down the pages that on which those pages you people will find that information. It is in your book, and in the book we people are doing chapter number 11. Okay, so this is the chapter that you people will be doing, and it is page number 128. So इसको mark कर लो, page number 128. Now I am talking about the colors of indicators. Here, the color of indicator, the color of blue litmus paper in an acid, and what is the color of blue litmus paper in a base. So you have to memorize these. I have also done this thing in the copy as well. After that, for the bases are, now it's very clearly written what bases are. They are there's a difference in definition of bases and alkalis. So bases are oxides. Okay. Now the next thing is what do you mean by the term corrosive? Corrosive mean they can cause harm to the skin. So either it is an acid or it is an alkali. It is going to produce or it is going to do harm for the skin. Next one is ammonia. You have to memorize the formula of ammonia because ammonia is also an alkali, and it is a weak base or weak alkaline solution. Here they have got written the formula of hydroxides. Memorize all these formulas. Now the color of the indicator. Here they have just written litmus, but I have taught you that red litmus paper, what is the color of red litmus paper in acid, what is the color of red litmus paper in alkali, and then what is the color of blue litmus paper in acid, and what is the color of blue litmus paper in alkali. So if it is a red litmus paper, it is not going to change its color in acids, it will remain red. And if it is a red litmus paper in alkaline solution, it will turn blue. So you just keep this thing in your mind, that what color of litmus paper it is asked in the question, and where they are putting it. Either they are putting it in an acid or an alkali. Next one is next one is methyl orange. Methyl orange is just going to give you a color, red color in acids and yellow color in alkaline solution. Next is thymolphethylene. Thymolphethylene is the one which is going to give you a colorless solution in acid and blue color solution in alkali. So you have to memorize the color of paper, methyl orange, thymolphethylene. These all things in the for your cat. Okay, now the next one is, now this why this particular 11.2 is important, because this 11.2 is the one which is going to give you an idea about what are strong acids and what are weak acids. And you have to memorize how you are going to write down this equation. This is basically ionization of HCl, or ionization of any strong acid. So it is going to produce H positive ion and Cl negative ion. So memorize how you are going to write it down. Next one is that this is very important. The solutions of all acid, they contain hydrogen ions. Similarly, when you are uh, dissolving a sodium hydroxide in a water, so it is again going to produce Na positive ion and OH negative ion. Now I have a question over here, that are the solutions of this acid and alkali, are they responsible for the conduction of electricity? What do you think? Will they conduct electricity? Yes or no? Yes, they will. Because conduction of electricity, for conduction of electricity, a thing which is very important is the presence of ions. And yes, here we have got ions, and here we have got ions. So both of these solutions, they are responsible for conduction of electricity. And one more thing that we people have done in our lesson when we were doing how to differentiate experimentally between weak acid and a strong acid. So that was also that take those solutions in a beaker and attach it to a circuit and then connect it with the bulb and then see if the bulb glows, then your solution is able to conduct the electricity. So in the weak acid, this the bulb will not be very brightly lit up. But in the strong acid, the bulb will be very much glowing. So because in strong acid, ionization is 100%. There are more ions in a strong acid solution, because strong are the ones which dissociate 100%, and weak are the ones which do not dissociate 100%, and we write down the word partially dissociate. Okay, after this, the pH scale, we already know what are the different values for pH scale, what is the range of pH scale, what is if somebody is asking you in the question the pH of a strong alkali, so you may write down these last three values for strong, and for the weaker one you may write it down, this is for the weak, and here this one is for the weak acid, And these ones, 1, 2, and 3, you may include 0 in this as well. This is for the strong acids. But if you write, and the other thing is, please look very carefully in the question. Are they asking for a pH value, or they asking for the range? Because in question they ask you for what is the range, and then you write down the whole 0, 1, 2, 3. So just give one single value there. There's no need to write down multiple values. Okay. Now these colors you have to memorize. If the pH is 1, the color of universal indicator is 1. If the pH is 2, 3, or 4, then it is an orange color. 5, yellow. 6, yellowish green. 7, green color. 8, green and blue. And then from 9 to 12 it's blue, and then 13 is violet. Now why they haven't written 0, why they haven't written 14? 14 still it is a violet color. And if you are going to write, because normally the maximum value of pH that we consider is from 1 to 14, not from particularly from 0 to 14. So I suggest you to start your pH scale from 1 and end at 14. Just skip the 0 value. Next one is pH meter. We have done, I have shown you a video related to this pH meter activity in the lesson. And there we have seen that if the acid was a strong acid, and the pH value was less, and if it was a weak acid, pH value was greater than that. Okay, and these two equations, again, very important equations. And this is the one, this sign is very important when you people are writing down the dissociation equation or chemical equation for weak acids. And this is the most commonly asked weak acid example, and this is ethanoic acid. And I have also asked you people to memorize the formula of this one. Next we have, now here, complete a strong acid is, it completely dissociates into its ions. Weak partially dissociates into its ions in a solution form. Next comes the reactions of acids and bases. Now reaction of acid and bases, these are very important ones. Acid reacting with a metal, producing salt and hydrogen gas. Acid reacting with a base, producing salt and water, no gas is produced in this reaction. And acid reacting with a carbonate, producing three things. So again, you have to memorize it. You have to learn how to write down a balanced chemical equation for these ones. And we have done a written practice of these equations in our copy as well. Okay. After that, this particular diagram is for when magnesium is reacting with dilute sulfuric acid. What are the observations? Now, this is very important. Then when this reaction is happening, what are the observations? Observation is what you are able to see, because this particular acid is linked with this one, so it is going to produce salt and water. This salt is soluble. You cannot see this salt forming in the beaker. What you are able to see? You are able to see the bubbles. So your observation number one is bubbling. And you cannot write it down. Bubbling of hydrogen gas is seen, because bubbles for every gas are almost the same. No bubble is going to tell you I am hydrogen gas bubble, hello, I am carbon dioxide gas bubble. So bubbling, the bubbling is formation of bubble, will only give you a hint that a gas has been produced. Which gas has been produced, then you have to see from the reactants that which type of gas has been produced. Next one is if they ask you for another observation, then this magnesium which is here, that we have made it react with sulfuric acid, it is in solid form. And this solid, it will, when it will start reacting with this thing, this solid will decrease in mass. So if in the beginning of the lesson you are able to see a long narrow strip of magnesium ribbon, by the end of the reaction, when the bubbles have been formed, when they all are going to be formed, then you are going to not able to see the same length and thickness of this magnesium strip. Because it has reacted, it will reduce in the mass. There would be a reduction in mass. Reduction in mass. So these are the two observations for this particular reaction. Now the next one is this particular example, that how now for the base they have given you two examples. One, they have given you a sodium hydroxide, another one they have given you copper oxide. For sodium hydroxide they have written a word alkali, for copper oxide they have written a word insoluble base. Now these are the same reactions that I have done with you in the lesson when we were preparing the salt. So this whole chapter is interlinked. It's not like this, that the thing that we are not studying in salt method of salt preparation, they are not included over here, because the reaction is the same. The reaction is the neutralization reaction. Why these reactions, the ones that I have ticked and the one I have I'm going to highlight now, why these reactions they are called neutralization reactions, because water has been produced here. Here, the water has been produced here. So if in a reaction an acid is reacting with an alkali and this water molecule has been produced, you are going to write it down that these are examples of neutralization reaction. And why both of these reactions are important, because both of these reactions are for the preparation of salts. So you should be able to write down your reaction of acid with an insoluble base. You should be able to write down your reaction of acid with an alkali. The only difference is in the formation of how many water molecules are formed. But every time salt and water will be produced. Now, this particular beaker is for this reaction where sulfuric acid is going to react with copper oxide. Copper oxide, what is that now? Yes. Another important thing is start learning the color of different compounds right away. So copper oxide, the color of copper oxide is black. And when this copper oxide is going to react with, and when this copper oxide is going to react with H2SO4, it is going to produce copper sulfate. And we all know this thing very well, that copper sulfate solution is blue in color. That is why this is blue. So although both of these compounds, copper is a transition element. Both of these compounds, they have their own color. Sodium chloride is not a transition element or compound. Sodium is from group number 1. So the color of solution of sodium chloride would be colorless. But here again, copper transition element, it will give you a colored salt. If it is copper oxide, it is black in color. If it is copper sulfate, it is blue in color. So please start memorizing it, these colors as well. Third reaction is acid with a carbonate. Now, what is the formula of a carbonate ion? It is CO3 negative 2. It can be any carbonate. Yesterday also I have taught you people about the carbonate, that carbonates are insoluble compounds except for 3 carbonates: sodium, potassium and ammonium. So if you react any carbonate with an acid, we are not dissolving it over here, we are reacting it. So irrespective of that carbonate is soluble or insoluble, carbonate is going to react with an acid to produce salt, water and carbon dioxide. Now the question may arise over here, is the reaction of acid and carbonate a neutralization reaction? Yes, it is, because water is produced. So in this whole chapter, there are two type neutralization reactions. One is with carbonate, another one is with carbonate, another one is with this one, the previous one, sodium hydroxide and copper oxide with an alkali, acid plus base, acid plus carbonate. Both reactions are uh, neutralization reactions. Now let's talk about the observation when you are reacting a carbonate with an acid. So in that one, what is formed? Again, because there is a gas, very common example is bubbles. And again, you have got a solid, one of the solid reactant, the mass of calcium carbonate when it will react, it will also decrease because it has reacted and formed this salt and water and carbon dioxide. So the mass of calcium carbonate that you have taken in the beginning of the experiment, now it has been reduced. Okay, now these were the three reactions of acids, and there are two reaction of bases that you have to memorize. But the only thing is one acid of base, we have already done it here. Acid plus base, this one. So in the book, this reaction is not written second time because they have catered this reaction in the acid column. But you should memorize that there are two chemical reactions for bases that you have to learn, and then there are three chemical reactions of acid with carbonate, base, and metal. Okay, so when a very common thing that we are going to do is reaction of a base like calcium hydroxide with ammonium chloride or any ammonium salt. It can be ammonium iodide, it can be ammonium carbonate, it can be like any ammonium salt. Okay? So it is not necessary that it would be written chloride in the end, but it has to be an ammonium salt. And the things that are going to be produced over here is calcium chloride, ammonium, and water. Ammonia, again, it is a gas which is produced here. Next thing is this a neutralization reaction? No. Although in this reaction, a water molecule has been produced, but that water molecule is not produced by the reaction of an acid or a base or a carbonate. So there is no acid here. So we are not calling it a neutralization reaction. Okay. Next one is now this equation is very important. This is an ionic equation for neutralization. Hydrogen reacting with hydroxide ion and form water. Who is giving this H positive ion? Your acid. Who is giving this OH negative ion? Your base. And then a water is formed. Okay. Now these two ones, this particular thing you people have already done in your class project, that how the neutralization reactions they are important when you have acid reflux thing or when you have indigestion, how you are going to how you people are going to if the pH of salt is more it's acidic, what should be added to make it neutral? And another thing is that if the pH of soil is less than 7, it means it's acidic. Why it is acidic? Because of the acid rain or some rock which contain some salts or acidic thing, or because of the heavy use of fertilizers, your soil is now acidic. How you are going to change the pH of that salt? How you are going to bring the pH of that salt closer to 7? There are three ways by doing it. Because your salt is acidic, you want to add base. The bases that you are going to add will be limestone. Memorize the name limestone. And what is the formula of limestone? It is calcium carbonate. Memorize the word lime. Lime is calcium oxide. What is slate lime? So you can add any three from this. If you are writing it down, add sodium hydroxide to your soil, and that is also a base, and it is also going to neutralize it. That doesn't make any sense. What practically you are using? You cannot write down the name of any alkali or any base here to neutralize your salt, because we do not want the pH of our salt to change very drastically or go to the alkaline side. So these are the three things, only these three things they can be added. And these, the formula, why I am asking you to memorize their common name and their formulas, because they are asked in exams, either in MCQ, even if you they are not asked in this particular CAT exam, they will be asked somewhere in later stages in your exams. So you have to memorize, and this is very important because students, they get confused in the name and the common name and the formula. So we will be reading about these limestone, lime, and slate lime many more time in the lesson. Uh, in the lessons that we have to uh, do later on. Okay, now a closer look at neutralization reaction. I have already done this with you, that how you are this titration thing, how you are going to carry out the titration, what you are going to pour it in the conical flask, what you people are going to add as an indicator, till what time you people have to add the acid into this particular solution. Now this is very important, that you have to, if somebody asks you define acid, you cannot write it down a substance who has got a pH less than 7. You have to write it down, acids are proton donors. And what is a base? They are proton acceptors. So these are the definitions that you are going to write down. And if you have to write down a definition for weak acid, then write it down, a substance that donates proton 100% in an aqueous solution. So anything which is related to proton donor or acceptance regarding the definition of acid and base, only those will be considered correct. Else, any definition will not be considered correct. So these two pages, they are related to proton donors, proton acceptors. Okay, now again a very important thing, that is oxides. What an oxide is? Oxide is basically, what an oxide is, a compound having this particular ion in its formula. Now, basic oxides are the one which are metal oxides. Either it is a group 1 metal, group 2 metal, transition metal. Memorize these equations. Why we are calling them basic oxides? Because these oxides, when they are dissolved in water, they are going to give you an hydroxide. Sometimes the oxide, it doesn't dissolve in water, like the oxide of this particular one, copper oxide. So we are going to call this thing as insoluble base, because in the beginning I have told you that what bases are, and why we are, how we are going to see this thing experimentally, how we are going to write this thing experimentally. We are going to write this thing experimentally by doing this particular reaction, by checking the pH of the solution with a litmus paper. And again, if the color of red litmus paper turns blue, it means the solution is alkaline or it's a basic one. Next one is this equation, very important one. Acidic oxides, all the non-metal oxides, they are acidic oxides. Now, carbon dioxide, sulfur dioxide, phosphorus oxide. These phosphorus oxides are the ones P4O10. Memorize the formula, the balancing one. Why it is written P4? Because phosphorus, the way Cl exists as diatomic, because but it's a gas. But phosphorus, it has 4 atoms of phosphorus combined together. So it is written as P4 in the equations. And it is not a gas, it is a solid thing. So we write down the formula when we are writing the for phosphorus. it is P4. Next, when you are dissolving these particular oxides, now all the mm, non-metal oxides, they are soluble in water, and when they are dissolved in water, they will form acidic solutions. Amphoteric oxides, there are two examples of amphoteric oxides that we have to memorize. One is zinc oxide, another one is aluminium oxide. But the reactions or the chemical equations that you people have to learn is aluminium oxide with HCl to produce this one, aluminium oxide to produce with sodium hydroxide. Salt and water, salt and water. So if this oxide is reacted with an acid, it will act as a base. And if this aluminium oxide is reacted with an alkaline solution, it will act as an acid. So they can act both as acid and base. That is why they are called amphoteric. Because if you react them acid with acid, they will act like a base. So they reacted with both acid and base. But if you have got, for example, HCl and you want to react it with H2SO4, this reaction cannot happen because two acids cannot combine together, react together. Or if you have got carbon dioxide and you want to react with an acid, because this is an acidic oxide, again no reaction will happen. Similarly, if you have got, just suppose, sodium oxide Na2O and you want to react it with magnesium oxide MgO, they will not react together because both are basic oxides. But amphoteric oxides are the one they can react with acid and base both. And memorize their examples, memorize their equations, memorize their balancing. Then neutral oxides are the ones which are neither acidic nor basic. And the examples are carbon monoxide, N2O, dinitrogen oxide, and a very well known is water because the pH of this is 7. So these are the neutral oxides. Next one is I have given this particular task to be done in copies, and it was done in a Zoom class. If in a online class, if you people haven't done this thing in your copies, please do it. Next come one is yes, we are done till here. So this was the whole lesson thing. In tomorrow's lesson, I will give you a written practice of it. But there you cannot ask me what is the formula of this sign, what is the formula of that sign. Do you people have got any question related to it?